Hello and welcome to a new session of the g.HIsys prototyping tutorial. My name is Patrick and today I'm gonna show you how you can create an evoked potential processing chain within MATLAB Simulink using the g.HIsys toolbox, and this within a few minutes. So let's get started. So from the g.tec Week 2020, we're gonna start the g.HIsys. And we land at the Simulink start page. So from the Simulink start page, we create a new model, a blank model, because we want to start from scratch. So for our evoked potentials signal processing chain, we need some blocks. So we need to add them to our Simulink models. There are basically two ways to add the blocks to the model. First one is to use the library browser, and then you can browse to g.HIsys, library, and select the block that we need. So we need a visualization block called the scope. We click it and drop it in our Simulink model. The other way, and the more convenient way, is just to click in somewhere in the Simulink model and start typing. For example, we also need a from file block. So we start typing from file, and then in the list we can select the block we need. So we need this from file block, and then it's automatically added to our Simulink model. For this tutorial, we're gonna use pre-recorded data of an vibrotactile evoked potentials experiment, and this file is installed with the g.HIsys installer, and the name is GEP demo data. And we want to have double precision of the output and then know that the data was recorded with a sample rate of 256 Hertz. Okay, we apply the data, and we connect the output of the from file to the scope. So now, as we don't have an amplifier here which paces our Simulink model, we do need the real-time clock. So we're also gonna add the real-time clock block there. Click it and it's added. So the real-time clock will basically pace down the simulation time to real time. So now I also gonna set the stop time to infinite to let the model run as long as we wanted to have it. And then we're gonna take a look at the data, at this EP demo data. We press run, and then we can inspect our data in the scope. We just double click the scope, and then we see our traces coming in. We see that we have 8 EEG channels, and then we have 2 additional channels which holds the trigger information. Channel 9 will hold the non-target trigger, and channel 10 will show the target trigger. And we're gonna see the trigger in a few seconds. Okay, so we're gonna see in this channel and that channel the triggers coming in. So for the non-target, they are much more frequent than for the target. And yeah, the subject was told to focus mainly on the target stimulations to evoke the potential. So now as we see the data, we can continue with building up our processing chain. So which blocks do we need for an evoked potentials signal processing? So first of all, we need to separate the continuous data stream into target and non-target frames. So we call this process trigger. So I type in trigger hit enter, and then the trigger block of the g.HIsys will be added to the Simulink model. We connect the input data and double click the block to configure it. So with this trigger we can trigger the data, and out of the continuous data stream we can extract trials or epochs or chunks, data chunks. Therefore we need a trigger channel, and first we do it for the non-target trials, and the non-target trigger was presented on channel 9 of our data. We don't need the external threshold because we want to use the threshold or the value of the channel itself. We want to have a window length of 700 milliseconds, a pre-trigger time of 100 milliseconds. The sample time is already correctly set, and we want just a standard validity mode. Okay, so we gotta name this block non-target trigger. So now the data is coming in, and then it's split it up into chunks of 700 milliseconds for the trigger. So for each simulation we will get 700 millisecond long chunks or trials. So basically what we do for the EP is that we need to get rid of all the noise. So to do that we normally use an average block. So I type in averaging, and then from the g.HIsys library the averaging block is added to the Simulink model. I connect it with the data from the trigger and the validity from the trigger, and then we take a look at the parameters. So we have the averaging mode parameter, which is set to average all data. We could also add a moving average, but in this case the average all is good. We want to have the standard deviation calculated as well. Yeah, we don't do a baseline correction here, but the sample rate is also correctly set to 256 Hz. We click apply, and then we name the block to non-target average. Okay, and then we may want to visualize our non-target average. We can do this with the so-called vector scope, which is also within the g.HIsys library. We connect the data, the average data and the validity, and then we name the vector scope to non-target average scope. Yeah, so for the non-target we already have the processing, and we want to do the same for the target, but before I do that I need to also configure the average scope. I double click the scope to bring up the configuration panel. So it wants me to enter the sample rate, which is already correctly set, and the trigger offset. And the trigger offset, maybe you remember, in the trigger we set it to -0.1. So we're gonna set it the same here. I'm gonna show you afterwards why this setting is important. Yeah, so now we have our processing for the non-targets. So we go here and copy. That part. Because basically we want to do exactly the same for the target. We only need to change basically one parameter. This is the trigger channel. The trigger channel is in this case channel 10. We saw the least frequent triggers were coming on channel 10. We apply the changes, and I'm also gonna rename the blocks. And then we're good. So now we get two separated data streams. So from the raw data, we separate the non-targets and the targets, and we do the average. And then we can see side by side the target and the non-target. But mainly we are interested in having the target and the non-target one over the other to see any differences. And then we may want to analyze the significant changes between or differences between the non-target and the target. So for this reason, we implemented the so-called significance analysis block. So this block wants to have two groups, so group 1 and group 2, and then this block is performing a significance analysis among the groups. So we need to add the average of group 1, the standard deviation of group 1, and the validity. So same for group 2, the average, standard deviation, and the validity. And then this will calculate significant differences between the target and the non-target. So let's take a look at the parameters. Sample rate is already set correctly. The p-value, we're gonna use a 5% confidence interval, and we want to update our output on any group. So on any update of the target or non-target, we want to have the significance being calculated. And yeah, then we want to visualize all the information we have there. So we have a non-target, we have a target, and we have a significance. So for exactly this purpose, there is the EP scope of the g.HIsys library. We add it to our model. We connect it correctly. So we're gonna use the target average, the non-target average, the significance, and the validity. And then we are done. We also need to set the parameters there. So we have a sample rate of 256, and we have a pre-trigger offset of -0.1. Okay, so far so good. So let's start the Simulink model. So the simulation started. We can see the raw data coming in. Raw data is then passed to the non-target trigger, which splits up the raw data to trials. The trials are then averaged and visualized. And the same for the target. Target are separated from or extracted from the raw data, averaged, and then the significance is calculated and visualized. So we can take a look at the non-target scope. And the target scope next to each other. Okay, so we already see that there are some non-targets and non-targets coming in, and they are split from the raw data or extracted from the raw data. We already see they are basically on the same scale. So we see that in the non-targets there is no evoked potential, but as well we see it in the targets. Okay, so the next step is we take a look at the evoked potential scope. Okay, and here we go. So you see here the red line, which is the trigger onset for the target and for the non-target, and then we see the blue line, which are the target averages, and the red line, which is the non-target average. And in the background, the green area is the significance area. So we see around 300 milliseconds after the stimulus presentation, we have significant areas in almost all the channels. And this shows us that in this area we have a different signal, statistical different signal. Yeah, so we then can go on and say, okay, maybe I'm interested in the intermediate results as well. Then we can go here and say, okay, we want to have a safe data stream block from the g.HIsys. and we add it here after extracting the targets. And then we call the file which will be generated, the target trials. We enable this data storage via external signal, hit apply, and then we connect the trial data and the trial validity to the block. So with this block, all the targets will be saved to a file. And then we can use this file in an offline script within MATLAB to process this data any further. Or we can use even g.HIsys Analyze to process this data. So that was it for this tutorial. I hope you enjoyed it. You saw within a few minutes you can build some nice processing chains with Simulink using the g.HIsys tutorial. And yeah, see you next time.